So what does the digital microscopy laboratory do by your research? So basically the effort here is to provide you tools for your research. We don't normally do sample preparation. We can help, we can advise you on experiments, but the experiments are indeed your design. We at most give advice. In terms of this, we support really 3 different kinds of experiments. One, fluorescence microscopy and also phase contrast microscopy in terms of things that are fixed samples looked at in an upright microscope, often a fluorescence microscope, images taken digitally, and then time-lapse experiments with fluorescence with things inside cells, living cell experiments, either done as an inverted microscope or done with a confocal microscope as a series of Z things within the cell. Also, we provide you with resources to do confocal microscopy, both as an imaging tool, but also as a dynamic tool for doing time-lapse in cells, as a way also to do photobleaching experiments or photoactivation experiments. Photobleaching and photoactivation experiments are particularly important as a way to give you dynamics, to study sort of protein interactions, protein exchanges, and there's a possibility of doing FRET, that is, fluorescence energy transfer experiments in terms of close interactions between proteins. In addition, we allow you to go from the level of light microscopy. Light microscopy is something where you have a limitation of resolution of about 200 to 300 nanometers, that is 0.2 to 0.3 microns in the XY dimension, about 0.5 microns in the Z dimension, to the level of the electron microscope. In the electron microscope, you can go to the nanometer type level. And in addition, if you look at protein complexes, particularly in the frozen hydrated state, you can go to almost the 10th of a nanometer type level, almost atomic dimensions. In terms of supporting sample preparation for the electron microscope, we have the ability to do thin sectioning for you, either as plastic embedded samples or as frozen hydrated samples. We can help you and advise you through the actual sample preparation process. We have the ability to do high pressure freezing, which is the current state-of-the-art approach. We can also support you in the more dated techniques of chemical fixation. We can provide freeze substitution as a way to go from high pressure frozen samples into plastic, which can then be readily sectioned. We have the apparatus, a plunge freezer for doing plunge freezing for protein complexes, and also in certain cases for cells. In addition, we then have a 200,000 volt electron microscope, a Techni F20, which is set up to operate either 200 kV. 200 kV is designed for doing thick sections, for example, tilt series electron tomography, which you tilt the sample and eventually then do back projections to give you a 3-dimensional sense of things within a thick sample. It's also set up at the 200 kV to do protein complexes, where you want the cohesion to the beam that comes with a higher voltage. We have the microscope also set up then at 80 kV. At 80 kV, you have the advantage of higher contrast. So we cover a range of about 1,000-fold in resolution. Everything is collected digitally. So in terms of using the facility, Jeff Kamakowski does the day-to-day hands-on operation. I'm Brian Storrie, and I'm responsible for sort of giving you the overview and sitting down with you and talking through protocols and where you could go. So please see me. My office is in room 262 in Biomedical 2. The actual laboratory is downstairs in Biomedical 2 on the first floor in room 136-2.